get that on here. So again, we're going to go into R3. Let your basis in R3 now be one, two, three, 3, 2, 1. Zero, 2, 0. Now just to be sure that this forms a basis, let's just do the dot products. If the dot product of this and this is not 0, then these two are not orthogonal. Dot product of this and this is non-zero, then these two aren't orthogonal. If this dot product is not 0, these two aren't orthogonal. Well, it's very simple. All these dot products are positive. None of them are 0. So you can calculate it yourself. But now, you let this be a basis of R3. R3 we know has dimension 3. We've got 3 vectors here. None of them are orthogonal to one another, or to any of the others. It follows we have a basis. Okay, so here's our basis. And I should have said, and I'm just going to kind of notate it. Okay, this will be V1, V2, V3. Here's how we go. Okay, now we're going to start with U3. Now we're going to start with V3 and project it onto V1. So we're going to let actually I'm going to do U2. I'm going to start with U1. Okay, let U1 equal V1 divided by the magnitude of V1. And calculation straightforward. Square this, you get 9. Square this, you get 4, which makes 13. This makes 14. So there's our vector U1. I'm going to actually use a third letter here. I'm not sure your text does this. Okay, I'm labeling these U1 and U2. I'm going to double these. I'm going to make them W's. Well, I'm going to make this one W. This is still going to be U, but I messed it up, so I'll erase it and I'll get rid of the let. Let's write it out correctly. Okay. Let W1 equal this. We're going to let U2 equal U1 minus the projection onto I'm just having all kinds of trouble here. V2. Minus the projection onto W1 of V2. Okay. You know the projection isn't going to be 0 because W1 is just parallel to V1, which is not perpendicular to V2. So the W1 is not perpendicular to V2. So the projection is not going to be 0. Okay, so U2 is going to be V2 minus this projection. This is going to give you a vector perpendicular or orthogonal to W1 and we're going to let W2 equal U2 divided by U2. The next step I'm tempted to do in 2 steps, although you can do it in 1. Yeah, I'm just going to do it in 1, and I'll maybe explain. Okay, now let U3 equal V3 minus the projection onto W1 of V3. And this is going to subtract off the part of V3 that's parallel to W1, meaning the part that's parallel to V1 actually. Okay? So we subtract that off. Now that doesn't guarantee that this vector is also perpendicular to V2. So to make sure that happens, we can subtract off its projection onto W2 of the same vector, because we're trying to take away the parts of V3 that are parallel to V1 and parallel to V2. Okay, how do we take off the parts that are parallel to these vectors? Well, if you think back to what we did originally, this projection is the part of V1 that's parallel to V2. And we, for reasons I hope you understand by now, subtract that off, leaving only the part that's perpendicular. Okay? Well, we take off the part that's parallel, part of V3 that's parallel to W1, and the part of V3 that's parallel to W2. And we have it. Okay? We have what's left, which has to be perpendicular to both W1 and W2. So U3 is perpendicular to W1 since we've subtracted off the part that's parallel to W1. And U3 is perpendicular, did I say parallel before? It's perpendicular to W2 because we've subtracted off the part of V3 that's parallel to V2. So there we have it, except now we want to normalize U3. So we're going to let W3 equal U3 divided by the magnitude of U3. Well, that's it. Okay, W1, W2, W3 are now all unit vectors, and each is orthogonal to the other. This is an orthonormal basis. If you were in W4, well, you'd have a V4, wouldn't you? And as long as your V4 along with V1, V2, V3 make a basis, and of course, if you're in 4 dimensions, then the vectors of length 4. But if all those conditions hold, you're going to do the same thing with W4, or with V4. You're going to have already done this. You're going to already have your W1, W2, and W3. And then your U4 will be your V4, but then you got to subtract the projection onto W1 and the projection onto W2 and then the projection onto W3. So you'd have 3 of these projections to subtract. Nothing mysterious about that. That's what works. That can be proven with symbols. I'm not going to go through the proof. I'd like to, but it's introductory level course. If you understand the process and hopefully the reasons behind the process, then you're doing okay. Now, we see from this example that we can extend this to any dimension. Yeah, might get tedious, but it's easy to program it. So, and then you wonder, well, why should I have to do this? If we can program it, why not just do it? Well, you have to understand it. If you don't know what the program's doing, you don't know what's going on, and you can't visualize it, you can't use it. Okay? All we do is train you to use this, use this, use this, and use this. We might as well just write a program that uses this, uses this, uses this, uses this. Then we don't need you. Okay? Well, we need the flexibility of your mind, and this is why we teach you to think. Okay? And think through these things and understand more deeply than any computer, at least so far, can do. Okay. Now we could actually do this calculation, but it gets a bit tedious, and your text is going to have examples of these calculations. So there's nothing new to do by just running through this sequence of calculations. It's not going to be as obvious as it is in 2 dimensions. So there's really no point in doing that, so I'm not going to. Here's the process. You start by normalizing your first vector. Then you take your second vector and you subtract its component in the direction of the first, and then make that into a unit vector. It gives you your W1. That's all that's going on here. For V3, you subtract its component in the direction of now what we call W1, the normalized V1. And also its projection on W2, which is the normalized part of V2 that's orthogonal to V1. Okay, so you subtract off both of those projections. And if you got a V4, well, you subtract its projection onto W1. And then subtract its projection onto W2 and its projection onto W3, which are the normalized vectors that you get from these processes. And you normalize that, just divide it by its magnitude. Again, We're not going to make you do that for a 10-dimensional vector. Probably won't even make you do it for 4 dimensions. If you understand it in 3 and understand what's going on, then you're in good shape.